Alright, so we have a panel discussion where we talk about some important aspects. So the first one being, we all know how large language models have scaled to a great extent that it's available for consumption across the globe. And it's scaled well, let's be honest, economical. You're all able to pay for the $20, $100 cloud subscriptions and your chat GPT subscription. Although I feel they're being real assholes by having these subscriptions and also blocking some of the models. They use our data and then they just train the models and then they just block us from using the same models. So yeah, asshole is the right word for them, I believe. But on the other side, it's also a great discovery, and I think one of the most consequential technologies in the last few years, I guess. So we're going to talk about large language models, its impact, and what is beyond it. Definitely, a lot of researchers are talking about the dead end for LLMs and what's next. So we're going to talk in detail about that. And then we want to talk about some high-level ideas about world models and what they are. I think a lot of people are still confused. Like, I'm hosting this session, even I'm confused about the true definition of world models. I think some of our speakers are also confused. So it's a great place to break the myths and actually see where the North Star is for world models. And let's just try to talk about some key aspects. And then I think most of you, I think we themed the event around founders, aspiring founders, builders, especially who want to build in physical AI but are really looking for ideas and also the go-to-market strategy for deploying physical AI in the real world. So I think some of the entrepreneurs today who are on the panel are going to talk more about building a business around physical AI. It's not just about doing a research or reading a research paper and just being happy with it. I think we also have to look at the real impact of the technology in the real world. So I think that's where we're going to have most conversations on. And yes, so we have all the three speakers today. Great. So I'd like to invite our speakers for the first panel session. First one being Mr. Srikanth. Since he's standing, I'll welcome him first so that he just finds a seat on the stage. Yes, give him a round of applause. And next up we have Satyam Tiwary. He already introduced himself, but give him a round of applause as well. And our third speaker for today is Vivek Jaiswal. Give him a round of applause. Awesome. So we're going to spend the next 1 hour deep diving into the agenda that I just spoke about. But before that, I wrote introductions for all the speakers today, but I really want them to introduce themselves and talk about what they're building. Sorry, you guys have to repeat yourself yet again, but I think we can just deep dive into also what you're trying to do. Great, so let's start with you.
Yeah, hey guys. This is Vivek Jaiswal. I'm building Trekion.ai. I'm like a couple of months into the journey in this, and like many of you guys, I'm also relatively new to the field, and I'm really like stunned with the pace of development and the speed of this sector, to be honest, and the kind of research that is coming out, and just to catch up with it is it's like crazy. So before this, I was like couple of years doing industrial AI, where we work with factories to improve their productivity, how to reduce their downtimes, build them more efficient through using IoT technology and data. With those technologies and doing sales across Bangalore, Chennai, and the US as well. So at that time only, I got interested. Like what else? Like a lot of places, I saw the gap that I can also like probably build the robots as well, which are there in the factories. I could see a bunch of robot companies, mostly foreign, like German, Japanese, doing robotics. Not the like AI native ones or the smart ones, but probably very contained robots. So from there, my interest started in the space, and then last 3-4 months. So I was exploring, and now I'm like building the sim and eval layer for these industrial robots. So basically, we do train robots to perform tasks. We are building VLAs, world models, but then how do you say that actually it's gonna work? Or the certainty, how do you define those things more narrowly? So that is a problem that I've chosen to spend time and build on. Yeah, I think, thanks.
First of all, that's a great problem, I think, evaluations. I'm Satyam, Sentientx. We are building, so I'll tell you my story. We built a humanoid. That's how we started. We started the company and we rushed to start from finish in like a month, built a humanoid in Shenzhen. And it was a big spirited month of building something from scratch. We've built a lot of things before of this sort, so it was more a question of how quickly can you do this, right? And it was the fact that you can do this in a month, I'm not going to lie, was a kind of a disappointment, right? It taught us a lot about how quickly, if someone can do this in a month, it's like 2 people at that point. This kind of was a moment, and it led us to think about what are all the other pieces that we need to deploy, right? You have a humanoid lying here. How do you take this to a customer? So this led us through a whole journey, and I think we built very exciting products, and hopefully we'll be bringing some of them more publicly. We did a data layer, we built a data factory, Lumi, we built augmentation layer, so bringing them into various sim environments. We built, we're now hoping to build some evals as well. And now we're also looking at real world RL as a way to stitch the last 10% on accuracy. So we really see our way into really edge deployed, distilled models. We don't see it against world models. It's like you need the biggest world model and you eventually distill down to something your customer is happy with. And it's just 6-month-old company, and we're going to build a lot of exciting things which hopefully you will use as well.
Hi, I'm Srikanth. I'm the founder of xSpecies. We are building physical intelligence, as we call it, through dexterity as our core problem to solve. And we believe that some of the things like tactile sensing becomes very important in building the intelligence. So yeah, I mean, so we are about, I think we'll celebrate our first year by August. So it's been a crazy journey. So like Satyam, like we also started with building humanoids. We made a choice to build the wheeled humanoid, though it was quite exciting to build, a bipedal robot. Locomotion is one of the craziest problems to solve for. Seeing the robot stumble and eventually, make it walk is the pleasure everybody wants to have. But I think more practically, what will be deployed eventually first is going to be like wheeled humanoids. I believe like in various kind of settings, from industrial robots, from warehouses to factories, manufacturing, healthcare, and so on. So that's our aim. Like basically, manipulation being the core focus. So we are focusing on hands. So yeah, today robots already exist since 1960s, right? But why is that? Like we still have human labor. Like just yesterday I was in a customer site and they have 500 plus workers working on various kinds of tasks, and I can see how tired they are, and they work round the clock. And that gap has not been bridged in terms of what the traditional industrial robots could do versus like what the human most capable skilled workers can do. And that gap, I believe, is the lack of dexterity and the manipulation capabilities. So that's the focus with which we are trying to build, and we see huge amount of synergy that can come across various companies working across all the layers from data to hardware to models and so on.
Awesome, thank you so much. So it's interesting, I think our speakers are working on distinct problems themselves, but there's a lot of overlap in their work, so to say. But I think I'd request all the speakers to wear the research hat for the first half of the talk, and then as and when we gradually move forward, we can wear the businessman hat, so to say. Right? So it's very interesting. You can also see this trend globally that most entrepreneurs in physical AI, robotics are actually researchers and academicians. They're all PhDs and folks from college, and that's a very interesting trend. Like even in AI, that's a common trend that we see. And there's a specific advantage that you get when you're coming out of a research lab, and there's also a disadvantage, so to say, when you're trying to build a business and you're still hungover with your research lab experience, right? So it's a duality of things. But let's see, let's all be researchers for some time. Like you mentioned, Srikanth, robots have been around since 1960s. I think Shaky the robot was like technically the first robot with sensors and stuff like that. But I want to go slightly behind that as well. In 1950, there was a thesis published. It is called Computing Machinery and Intelligence. Can anyone guess who wrote that? Okay, it was Alan Turing. That's right. Yeah, someone got it. So Alan Turing wrote this thesis, and the first line of that was, I propose to consider the question, can machines think? Okay? So this was 1950s, and probably 1940s, just before World War II, but the thesis came out later. And then there's another thesis published, A Path Towards Autonomous Machine Intelligence by Jan LeCun in 2022, when he was part of Meta Fair Lab, and I don't know why they kicked him out, but yeah, he's basically out of Meta for some time. But he wrote this thesis, and then that is where he mentions JEPA for the first time, right? So, and I wrote some questions that he asked from the abstract. How could machines learn as efficiently as humans and animals? How could machines learn to reason and plan? How could machines learn representations of percepts and action plans at multiple levels of abstraction? So Alan Turing asked the same question in 1940s and 50s, and Jan LeCun asked the same questions in 2022. I don't know what happened in between, but we're still asking the same question, and we still haven't answered these questions. So I think the question goes back to the panel. I want each one of you to interpret your own ideas about human intelligence in general, and then we can see if we can, continue the conversation based on the answers.
Yeah, so human intelligence. So I think what I've seen, like right now researchers also doing is like taking a lot of analogies from how the humans think, how we perceive the world, and then trying to draw those analogies into the robot's thinking. So like starting from like perception of the senses that we have, so having a multimodal perception, so have a vision, and then action, like various kind of sensing lidar and other things. So one of the things I think Jan LeCun's JEPA model, as you mentioned, one of them is like how it differentiates it from the other world models is around like how he works on the latent space, right? So and not like generating every pixel that you need to know for them to predict. So in that way, that's how humans also do, right? Like when we are talking, we have a certain like perception where there's a focus area and there's a lot of noise. So like that's how we perceive things. We like take and try to focus on things which matter for the action to be taken. So in that way, I think there's a lot of analogies people are drawing. I see a bunch of folks trying to make neuromorphological models where they're like, in fact, transformers, as you see, like the neural networks, they're all derived from how like brains work, right? With multiple signals coming, and there's like weights given, and then you decide whether it's activated or not. So I think that is one way of like going ahead is what people are trying to figure out. And I think the last thing that happened, which was the scale of putting more and more data, that also has, that LMs have basically established that if you give enough data and compute, basically brute forcing the approach towards intelligence. But in physical AI, I don't think that might be working because the scale is too wide, right? The modalities and the long tail of edge cases, basically. So I believe there has to be a smarter way to solve things. I also don't know what's the way, but my observation of the space on how it's going towards is towards draw analogies from humans and then see how we can make things in a smarter way. In fact, in the data learning also we are doing so. There have been papers published which establish that the quality of data is much superior than the quantity, right? So there have been models where if they have been trained with very accurately labeled and well thought of scenario specific training, if they are trained on, so their performance versus a model which has been brute force trained on multiple orders of magnitude of data, they still outperform. So these are some of the thoughts which come to mind, how we can scale the learning of the models. So I guess as we go ahead, I think we'll know more. Yeah.
So when we talk about thinking, immediately the question becomes, what are we thinking about, right? So I would say that whether it is vision capabilities coming from models like CLIP, or whether it is new abilities that we are expecting to see, encoders that represent the world in a certain way, learning these representations are the key first step, right? So there is no debate with learning representations. Better representations, more interesting thoughts to be had. But then the question becomes then there is another question, and that is thinking, right? So what precisely are we talking about? So the best to my understanding, thinking, for example, when it comes out of methods like GRPO or other methods like that, it seems to come from two things. There has to be a teaching regime, usually some sort of data that we have come up with which is useful for teaching, but then also paired with a learning objective that can learn from it. So for example, the closest thing to thinking that we have experienced in a model is probably when it thinks through a math problem till it reaches a solution, right? So it's almost a goal-directed objective that's leading to thinking, and sometimes it can be as simple as search, as in AlphaGo, right? So what are we ready to call as thinking is some goal-directed searching that this agent goes through. And when it comes to robotics, why should it be any different, right? So we have something to think about, representation learning, and then some mechanism to think about it, and that maybe the methods that exist already may be already used. I mean, if you have a RL environment, why couldn't GRPO type methods still yield some value, right? So already we are seeing in methods like SERL and those type of things where real world reinforcement learning can take you to 100% manipulation success rates. So why should, I mean, I think the recipes might already be in place. Probably the missing bit is representations. So how do I, if I've been in this room, right? How am I representing it in my head? I don't think we have a very good way of doing it in models. So I think maybe the representation learning lags more than thinking in that sense, in what I can see.
Let me just give you a fun example, right? Like 4 years ago, like I was watching this World Cup, like football World Cup, the one that is happening right now. There was this match between, I think it was Argentina versus Netherlands. And then Messi, I think he, like, known for his passing, dribbling skills. Like he figured out a pass between like 4 to 5 defenders in front of him, and he saw the run of his teammate, I think Molina. I think he just made a run, and he threaded that pass, and then he, without even looking at him. So that's basically the state of the art. You can call world model in physical world in reality, right? Like that's the golden standard where it is versus today's I think that's so what exactly is required to be able to do something like that is right, like when you think about it, it's about 3D awareness, like spatio-temporal awareness, right? So which is what is lacking in some of the VLMs, like we are talking in the context of VLMs, right? VLMs and VLAs, and VLAs have done remarkably well, right? And today you see like some of the state-of-the-art methods like Pi 0.5, 0.7 to Brute and all of the open source models that exist, and even closed source models shown crazy amount of abilities. But we still don't have robots that can do all kind of tasks that humans can do, because a lot of these models have been trained not with the objective of doing in the physical world, right? Like evolution happened from LLMs to then VLMs and then extended to VLAs. And the objectives of VLMs was actually to figure out like semantic awareness, right? So that does not naturally translate to spatio-temporal awareness. So for example, I'll just give an example. Let's say you take a VLA and then it show you a 3D world inside of a car and ask it to count the number of handles inside it, right? Can it do that? I doubt it can do that, because most of the data it is fed to is like with an egocentric point of view. So it doesn't, so when it actually has to construct the information from multiple viewpoints. So, and then reconcile that all these viewpoints actually represent like a 3D world, and I am actually in the center of it. So that degree of intelligence does not exist in current models, is what my understanding is. And I think that is what has led to all these initiatives of building world models, where vision is like a first-class citizen and not like as an afterthought. Right? So today, all these LLMs, I mean VLAs, have extended from the work of LLMs, and you took the LLMs and then added vision modality to it, rather than starting from vision as the first-class citizen. So I believe like that's where like we are seeing this spate of all these new startups emerging from like World Lab, like FAD to EMI from Jan LeCun and so on. So yeah, I think like we have to figure out like how best we could actually come up with the world models that can have this spatio-temporal awareness.
Sure, thanks for your thoughts. So I think we all generally agree that human intelligence is by virtue of a few factors. I've just listed a few. It is our memory power, our processing speed, our imagination, the capability to imagine things, and also grounded intelligence about our real world. Right? We talk about physics awareness. Let's just say that's, I think, the most important conversation that we are having around building world models. So I think humans have grown and evolved in a world which is grounded in all these things. And let's just talk about creating artificial intelligence to translate the same thing. I think large language models has been an amazing effort to replicate how we interpret thoughts and probably build a chain of thought reasoning in a conversation, and also provide relevant answers in a conversation, so to say. I think that's a good start, but also everyone's darling in AI, Yanli Kun again, goes on to say that LLMs are a dead end for achieving human level intelligence. And he gives a few reasons, which I noted down. He says there's no grounding in the physical world for large language models. They have mostly rested themselves in servers and devices, and it has not really felt the real world out there. And it also lacks primitive reasoning and planning skills in a spatio-temporal world. It has no awareness of how to navigate the real world. And there's also no persistent memory. I think most of it is limited by the capabilities of silicon, to be honest, today, right? So I just wanted to understand, I'll throw the question to the panel. Anyone who feels it's relevant to answer, you can. Is the design of large language models flawed as an architecture for it to not be relevant in the physical AI space? Because we're also talking about companies like Roda.ai, which is doing direct video action models, which is basically saying that we are not going to involve language as a backbone at all. So is it the architecture that is fundamentally flawed to scale into the physical AI space, or is it more of the challenges that we face in compute and the way we have designed systems, so on and so forth? So generally you want to understand what your take on LLMs and beyond that.
Sure. LLMs as a way to write code has been basically the smartest thing we see, right? We can ask it to do something and it would use code as a way to get that outcome. So fundamentally, the coding models as a policy have not been so flawed because they have been able to learn against verifiers which ground them in reality. Eventually, there's only one right answer to a particular math question, and that has grounded it already in certain regards. The other regards where it has not received grounding is the trouble. So if, for example, VLMs do not get any feedback against temporal or even spatial things, they are unlikely to learn that. So whether transformers are the right backbone or the denoising system is the right backbone, it's hard for me to answer that because it eventually would be down to efficiency what eventually prevails. It's not simply a question of whether a transformer can learn that or not, or whether a diffusion only system can learn that or not. So people are currently doing two tower where you mix transformers as well as you mix transformers with video model, and maybe that's just a way of consuming more data so that we get that grounding. I mean, fundamentally, the next frame prediction that we are seeing in video models or world models is a way to train on that. So I wouldn't, personally, I don't obsess too much about model architecture at that level because it's an efficiency question, and it's a question of whether we have the capacity to learn what we are learning. I would think more about learning objectives and setting them up in a way that whatever we are trying to teach can be taught. So if, let's say, spatiotemporal is my concern, temporality in general is my concern, sure thing, a video pre-training is going to be very important. But that's where I would leave that. You have other concerns like memory. So does video world model solve that? It's not clear because they're not efficient enough to have 24-hour memory or something like that. So I think we are in a place where architecture is yet to be invented to do robotics.
Yeah, I 100% agree with that. Like, so the response to LLMs, like BLAs, has been like the world action models as we speak, right? And some of these are like 14 billion parameter model. So can you actually efficiently run on an edge device? I think probably no, because like these are like based on diffusion transformers with iteratively updating themselves, and both training regime and as well as like inference is like very challenging with these models at this point as we speak. Hopefully we find efficient ways to run these. So yeah, I think while we went to the other extreme of actually grounding them in videos, but we are also again missing the common sense reasoning we get from LLMs, right? So yeah, so if you go the other extreme, how do you actually reconcile with having that common sense reasoning which is coming from LLMs is still a question mark. So I agree with this conclusion that like we have yet to figure out what is the right model. Is it actually just pure video based models, or it's actually like a combination of all these modalities, right? And we have also not really talked about the robots live in the real world where touch is like very important, and so that's yet another missing modality in all these models, right? Like how do you make sure like if you are actually like picking up a tomato versus picking up a bottle, like the kind of pressure forces that you need is very different. So how do you teach that? Like you need to train models with touch modalities as well, and so the architecture that can work across all of these is yet to be figured out.
Yeah, I think I'm on the same thought, in the sense that I'm also not too much leaning towards one side of things. I'm not choosing a religion as such, like which way I go, yeah, looking or the other way, because both have their own pros and cons. VLMs are not so grounded, as we all know. World models are better off, but then they also lack a bunch of grounding, in the sense the feedback loop that is needed, whatever data that we are using to train it, are they getting the feedback that the human gets when they are executing tasks, the force feedback, the object permanence, that understanding, how do we get that, and also the physics grounding, right? Like for example, fluids and like general understanding of gravity. So those things also like probably the answer can be multimodal training or have like some better way of getting the data to train. But as of now, I don't think there is a clear-cut winner. And I think things like Cosmos 3, where I think they use both of the words basically to predict the future, the actions. So there is still like hacks and mix of a bunch of things which people are trying to make things work. So yeah, like not leaning towards any of thing. And as Satyam pointed out, like a good approach I believe is to like define what you want to solve, right? Like and then pick that and probably solve that instead of going so wide and fixing the general intelligence problem from the start. So I think that's a good way to go about it.
Also, let's not undervalue real world. So I have watched probably a few videos of making biryani, but can I make one? I cannot make one, right? So, and how would I learn, right? If I really wanted to learn how to make biryani, what would be the advice for me? I mean, if you have to teach me, you'd say just try making once, right? So, I mean, I don't go to a school to learn to make a biryani. I'd probably watch a video. I'd try to do it, right? And maybe I get to taste it at the end, and it's so bad I never try it again. Or I feel it was almost there. I just need a little bit more, and I'm motivated to try it again. So let's not undervalue whether it has tactile sensors, whether it does not have tactile sensors, whether it has radars. I mean, why think about humans so much, right? We get to have whatever sensors we can imagine. You know, the physics department gets to invent sensors and we get to use it, right? So it's not a concern whether it has force sensors or does not. It's not a concern what sensors it has. It should have way higher abilities than humans. It should be able to see through walls. It should be able to see far longer than we can. The human is not any sort of a limit, but real world is. It's the ultimate verifier, right? So in LLMs we get like some math assignments to verify against. In robotics we get the real world to verify against, right? And the real world never lies. It's a perfect verifier.
So the challenge is there is you can't verify against real world. If you're an autonomous driving car, you can crash and learn from it. So I think where this could point out to is like how rich you can build your simulation, so which is as closer possible to real world. So I think I've seen like efforts being done to actually match real world closer to simulation and simulation closer to real world. And if you are able to bridge that gap from sim to real, I believe like, you know, lot more. So we have seen that, you know, today's locomotion policies have been trained almost zero shot, like, you know, entirely in simulation, because you can create crazy amount of environments. But something like that has not been like successful in the case of manipulation, because like you have interaction with the real world, and you have to interact with objects. And there is also not just the notion of just the physics, because you are, so think of like an autonomous driving car, right? Like, so the moment you see a person walking, so the way he would respond to a vehicle will be very different from like a dog crossing the road, right? Like dog will operate very differently. So it's just not just based on physics, it's based on the innate behavior. So how do you model all of this? So if you can match that kind of behavior into your simulator, that's where you could actually like.
Yeah, so between simulators and real learned simulators, one of my excitements for world model is coming from social simulations. Because when we are acting in the world, we definitely have a sense of how the other person is going to behave, and we kind of can sort of drive our behavior with that regard. So I do think world models right now, they are very manipulation focused, but as they step into long horizon things, I think they can go beyond simulators and where we can have characters and test out human robots interactions. And so the world models are going to be fantastic for those things as well.
Sure. So that's why I like putting researchers on the same panel, and then let's just let them fight over things. It's the most fun thing to do. But I think I partly agree with what you said, because I also noted down something which says a 4-year-old child learns more about physics in an afternoon of play than an LLM could by reading the whole internet. So this is something factual and scientifically proven, so to say.
And so the question is, does the 4-year-old starting point, like when you are born to this thing, right? Do you actually do you have a pre-trained model, or are you starting to learn from scratch?
I mean, you have your genetics for sure, right? So that provides you some priority for something.
Yeah.
And 4 years of training.
That's the 4 years.
Yeah, that's what, like this 4 years of learning, right? Like starting to walk and then falling. So that also contributes a lot to the inbuilt physics.
Also, right now in sim to real, so when we are doing the humanoid walking around, for example, we would do what is called system estimation, system identification. And in that you would say, oh, my weight tends to be plus minus 10 grams, let's say. So you would use that, bake that into domain randomization. You would say, okay, my weight gets to be in this range. But biology doesn't cheat like that, right? Biology says, be any weight, be any age, you can walk, you get to walk. And so the real world in-body training clearly play some sort of role, and then there's something that you get to carry as well, like cross embodiment. Like you definitely get to grow older in your body, or and the model adapts. So it's very strange and it's inspiring.
I think about the pre-training, right? I was just talking somewhere else and I cracked a joke. I said people also remember things from their previous life. Some of them actually talk about the myth of knowing things from their past life. So that's probably one way you know things. And also in Indian mythology, there's and generally you have a saying that when someone's pregnant and then you're just talking about things and then you're advised not to speak bad words around this pregnant woman because the baby is listening to everything.
So pre-training started from.
It's already built its opinion. So I think the pre-training starts from somewhere. Otherwise, it's a miracle how babies pick up things as fast as they do. Yeah, I think let's get back to some serious, real conversations around data. I think I don't know who's in HSR or like Bangalore trying to collect data from vegetable vendors, raise your hands. From factory floors. No one's collecting data. Oh, that's the one hand. Mad respect. Okay.
I mean, just to be clear, we also collect data,
You do,
but
yeah.
not egocentric.
I noticed you're wearing a Ray-Ban Meta, so I think you're just collecting data all the time. I don't know.
I think it's on brand, so I bought one. Let's see, I haven't been productive with this.
Sure. So yeah, I think the next question was that, again, I think we have come to a good conclusion about large language as a backbone, to proceed further. The answer that we concluded on was, I think we still haven't formed the right architecture, so to say, to justify that language or video or what is, really giving us that benefit or mode. But we can talk about data because everyone believes that collecting real world data is something that can really help scale physical AI. So I know most of you are doing it as part of your businesses and ongoing efforts. And there is a certain unit economics to it, but on top of that, you are also talking about the quality of data and also the usefulness of the data as well. Without that, it doesn't make sense to just collect data. I don't know. Does it make sense to just collect sensor data from thousands of people when the sensor itself is flawed in some ways? But let's see. Let's take your opinion on that. Also, I'd love to get your thoughts on what will be the most consequential data that will be used to build our world models. Will it be synthetic data? Will it be real world data? Or is it some other form of data that you're thinking about? So just your ideas on data, because most entrepreneurs today are trying to build in the data space, right? And then they're going out without, I would say, with a lack of vision. Most parts. Yeah, sure. I think the laughter is justified. Even I laugh when I see some of these entrepreneurs, vegetable vendors, and people trying to do many things. Like we pay 700 rupees this hour, just wear a camera on top of your head and all. So, just your ideas on how do we go ahead with data?
Right. So data, right? So we have been supplying data in India, like from, I don't know, ages, I guess. From the LLM era as well, like I see there's big companies established providing data for training, curating the data, cleaning, labeling, and etc. So we have been the data economy, not the intelligence economy. I think the other way I was telling you, right? Like you're just supplying the data to the companies to provide intelligence and paying like subscription for the intelligence that they provide. So that aside, in robotics also what I see, like most of the founders who are building, they are probably not building the intelligence, they are just supplying to somebody who is building the intelligence. So yeah, definitely they don't know what they're doing. And coming to the actual people who are building, my understanding of the land is that, the kind of demands that I've seen, because I was also in this space collecting data or probably connecting people who collect data. So labs also don't know what they want, right? So like a few months back, they were like, we all need egocentric, we need action labeling. Now, after the prevalence of world models, they are like, we need just diversity. Diversity is the play. Now, in latest few weeks, I see people want like more modalities in the data. So people are like trying to get like cheaper tactile sensors, mocaps, body suits, etc. To collect the data. So I think they are also figuring out, and they have a bunch of money to actually figure out things. So definitely, I also think that as information-rich data we are able to collect, and if even like better if we have the feedback loops as well in the data, so that would make the models like more accurate.
What do you mean feedback loops?
In the sense that for an event happened, and what was the force applied basically to for that action. So that feedback of the action, like right now it's just like we have the video frames, but not the like what was the action that the hand faced, right? Like, so that was what I meant by the feedback loop. So I think that would be necessary to actually see robots working like faster. Like right now I see like I don't know, I'm also like trying to figure out why are all the robot demos that we see are like so slow, man. Like we all have to watch it at like 4x or 5x, and even though they're trained on so many hours. So I think it has to do with the force loop as well, how fast it can process. So I think more modalities in the data are definitely is going to be there in the data, and that's one conclusion definitely I can say. That's where the world is moving towards to build better understanding of the grounding.
Yeah, so we did not start out building data for other people. We started out by saying, what data do we need? And so we thought real hard, and we worried about quality a lot because simply because we are the main user of this data. When we built this data, we did commercialize it, and this is also our roadmap going forward. So for example, we are not building sim environments for other people. We are building this because this is what we need. Similarly, when we do real world RL, we don't do it because other people may need it, we need it. And we think our future platform users would need it. And so we go out with that mindset, and when it comes to data, yes, it's hard to know what is the right data. As much information in the data is better. My current understanding is egocentric with tactile sensors and skeletal, a good skeleton which doesn't fly about is useful for the reasons that humanoid companies require to train a whole body controller, and whole body control requires skeleton. Simple as that, right? And tactile is useful because we will move away from the way we train manipulation right now. We will move towards an object-centered approach. Already academia has moved in that regard. And so we'll be tracking objects, and we'll be kind of robot-specific embodiments would come and generate that trajectory over that object. So in that sense, I do think egocentric, it seems like nothing, right? Like it's just a video. But I do think it's very useful piece of information. Because all the value is downstream from it as to what can we learn from it. One thing I don't like is repetitive data, for sure. We don't do repetitive data because that's very easy to do. So you don't want convenience to be your main reason for doing it a certain way, right? It has to be giving you some special powers, like you owning this data should give you some better model, right? If it doesn't do that, then what exactly is data, right? So we want to kind of worry about what end behaviors are we looking for, and what kind of data. Like for example, let's just take an example. Let's say I'm a wire harness manufacturer, right? I mean, I recently saw a Y Combinator company doing this, and I thought that was a very interesting use of task-specific robots, where you get a PDF, here's a wire harness I need, and there are some bimanual robots that build it. So what's the input? Input is some design, right? Some AutoCAD design. And what's the output? Output is a bunch of wire harnesses at a certain throughput, right? So how does egocentric teach you this? It doesn't necessarily directly teach you this. So you have to kind of think about backwards from these long horizon objectives and how to collect data. I mean, you don't need to be task specific, but at least you need to be more interesting tasks, more interesting, more difficult long horizon requirements, and having the right input. Your task cannot be a one-liner, right? I would be really looking forward to anyone doing data where the input is a PDF in general, right? And the output is whatever actions, right? So I think there is a lot. I would in simple terms say that don't look at what people are doing as the only thing data is good for. Data is the ingredient through which we create intelligence, right, out of these models. So there is so much to build, because here there is no internet. It's like we make the Reddit, then we make the Google, and then we make the Facebook. We make the data sources. But is it all going to be YouTube? Probably not, right? It's going to be more opinionated data as well. So I would kind of ask people to consider more opinionated data.
Yeah, I mean, when I think of data, I look at it as the classical pyramid structure. So you have the internet scale web data, and then you have on top of it synthetic and semantic data, and then you have so egocentric video data. That's now the new flavor, right, like of data that everybody is seeking to acquire. And then you have the teleoperation data. And you may also have like real world data, like, I think there are very few people, any companies who are able to actually generate the real world data, but we see like, companies like Edgybot like wanting to sell real world data to the world. So because they have deployed like 15,000 robots and whatnot, right? Like I think, which is what is going to be like the most valuable data in the entire value chain, right? So I would say like, yeah, I would agree. Like the egocentric video data is going to be very valuable, especially if you have with tactile sensing, right? Like, and that's because like with all these layers of data, like most of the learning is already done. Like you know how to approach the object, but you don't know how to deal with the object, which is what you will need to learn through like both egocentric vision plus combination of your tactile sensing that gives you like pressure sensing, right? Like, but the problem is like after that, like how does it transfer to your own embodiment, right? Like that's where you would still need to have some specific data that corresponds to your own embodiment, right? Because like the transfer may not be like 100%, so that remaining like 5%, 10% of the data you still need to collect. So and some of the challenges that also exist is like how do you like, let's say if you so human hands like what 20 plus degrees of freedom versus like your hand or whatever end effector that you use may not have one-to-one correspondence. So how do you actually like deal with that? And also like there are still some open problems in terms of what should be your end effector, like should be like, is it multi-fingered hand or can it be like 3-fingered, 4-fingered? So all those variations are there, right? So everybody has a hypothesis around it and builds around it.
Right.
Yeah.
Yeah, I think I also forgot to mention about the like simulation data, the whole pyramid. Like absolutely, that's the way to go. And I think what I can like predict, personal opinion, is that like synthetic and the real world will eventually be the one which will scale once, and the egocentric and teleop might not be that useful because this is like time being we are doing this to like at least let the data flywheel fly actually. Once there are enough deployments, we would have like the real world data that is the most accurate data that they need. And I think simulation would also like definitely improve a lot they would have better like physics grounding. Even some of the limitations that are there right now might also improve with time, as we have better evals and like reduce the sim to real gap as well. So I think better simulation and like deployment at scale would be, I think, probably sometime in the future probably scales.
Yeah, I mean, when it comes to egocentric, my ideal data, I mean, I would love to buy this if someone has this, is one of everything. You know, one of every task. Just one of everything. No repetition, no diversifying environments, just one of everything.
Yeah, I mean, the challenge I see is like, especially with the real world data, is that like, you know, the deployments may be in specific type of industry, right? So what we have seen is that LLM scale better because they've been trained on very diverse set of task objectives. In fact, like without, it's a self-supervised approach, like to learn, right? So equivalent of that we don't have yet in robotics. I mean, that's a different thing. But besides that, like the diversity of data you cannot get like just purely from real world. So that's real world deployments. So
yeah, real world deployments are not diverse. I mean, let's say you're only selling to a certain type of customers. So well, that's not very diverse.
Yeah, right, for that specific.
yeah.
I think we'll have to get to this objective question: is that why are you making robots? I think that has to be the first thing before you answer other questions. But yeah, I mean, diversity, maximum diversity, not in terms of lighting, not in terms of other things, because we can do it in simulation eventually. We can diversify this data set. But I think just also long horizon things about just humans doing longer tasks. I mean, especially if you're going to have video models as an important part of the backbone, we need to train, I have a shopping list and here's the mall, get me stuff, right? So there would have to be even more long horizon data.
Great. So, very interesting conversations. I am actually a big believer of specificity of data collection for deploying robots for a specific purpose as well, because I think that's where unit economics works best. I'm not really sure of the accuracy and all the parameters that is going to lead to the success of the deployment yet. I'm not done a deep dive of that, but somehow I feel that it's going to save time and effort before building context of the whole world, where you're still trying to understand what's the real deal and what's noise. I think when you're trying to build a business out of this, specificity matters is my take. But
I mean, I'll add one more thing is that people sometimes, I mean, yes, egocentric is cheap to collect, but then eventually your customer is doing a lot of GPU compute on top of that, right? To actually make it useful for, unless they're training world models in which it goes right? So with the price of egocentric data falling at the pace it has been falling, the question is that why not just build on top of that? Why not use that that resource which is getting cheaper by the day? Why not build on top of that rather than try to compete in a market like that? So we do UMI data, and we do data that we can target on a bunch of our robots.
I also have a couple of thoughts. Now we are almost ending this panel session. I think this is to bring back the attention to building in India for the world, sort of a narrative. So I think the West is trying to crack generalizable robotics. I think that's where we are the pipeline and funnel for building such models, and that's why we are trying to scale data like this. But also being entrepreneurs in India, and when you're trying to build solutions for the world, again, data is something that we talked about. But then let's also talk about some real low-hanging fruits that you guys see and that you're trying to solve, that you can probably share with our aspiring entrepreneurs and people who are trying to. I heard a lot of answers, folks in residencies and folks in university trying to build, right? So they're all aspirational. They all love to ride this wave, but then it's also important that they're grounded to reality and also get a good feel of what the consumer side of things. Like a factory is a consumer of physical technology, or any sort of. I mean, in India at least, consumer robotics is still not a big deal. Like we still don't have enough robots in our houses to do any sort of evaluation, so to say. But then definitely factories have, and factories I think will be the biggest consumers of this technology for the near future as well. So I just wanted to understand, like, what's your conversations like with customers, and are they really aware of the potential of deploying these technologies yet, or are they also doing this as a exploratory sort of a thing, as a deployment? Like, are they intelligent enough, the factory owners, to do any of this?
Yeah, so I'll take it, Tabar. So I think definitely Indian factory owners want to automate. I think like we are among the most developed countries, we are among the least automated, right? And there is so much scope for automation. And I think I think the usual argument is the labor in India is cheap, so why bother, building automation, right? But I think that argument falls flat because you don't just consider labor just as a cost, right? Like it's also about when you have to build certain things, and it's availability. Like, do you have labor available? Like, so today, some of the factory owners say we look to hire 100 people, only 70 people show up. And when you think about labor cost, it's not just the cost of like what you pay to the person doing the work, but it's the entire thing that you need for managing the person, right? So all of those additional costs add up, and there is definitely a case to be made for automation in India, and eventually all of the business owners care about how fast we can actually grow the business, right? And when you think all of that into perspective, there is very strong case for actually automating at scale in India. So I think the bottleneck is actually more on the technology side of things, especially if you want to do more complex tasks that the skilled workers do. So I mean, there are obviously the easier things to be done are in terms of building AMRs, material movement and stuff like that. So all of that is can be very readily done today. Right. The next level is actually replacing those skilled workers, or not just replacing but augmenting those skilled workers, where there is all kinds of events happening that actually cause spikes in demands, and we need laborers on short notices. So all the business owners might want to actually definitely there is strong case for having robots being deployed. I think that's where I think there is definitely a need for Indian ecosystem to exist. In fact, there's also on the lot of companies are also setting up manufacturing bases in India. For example, some of the aircraft manufacturing companies are setting up manufacturing bases in India. Yeah. So the need for industrialization is on the rise in India. So I would say, so the Indian ecosystem must rise. Right. So that's what I would say.
Yeah, right. I think for India, it presents unique constraints as well as advantages, right? So I think we should use that to build a business from here. Building something out of scratch, which probably you won't find design partners here, is very difficult. So robotics is just not replacing also humans. It also creating something completely new as well, right? Multi-axis 3D printers, or maybe a self-driving car, things like that, or this washing machine. So these are also robots, but probably we won't focus there because for it to funded and the research cycle it needs probably won't get funded in the ecosystem here. So I think we should probably try to see how we can enter the ecosystem or the what's similar to the Western or the developed markets, maybe start from there, get an entry point, and then getting entry point in India, I think you have to have a shorter ROIs. Indians industries, that's my experience, they don't like go for like multi-year ROIs, you know. If it's like more than 2-3 years, they just don't want to, at least capex, so definitely they will not do. So you want to enter and have some immediate value, and then from there build some long-term partnerships with them in terms of that. Okay, you're providing some value, but then there's a chance they can increase, like bring more automation, bring more value. And I think with that, you should use that integration and that coupling, that you can couple yourself with their system and then use that to collect data, have a very tight feedback loops. And then from there, probably you can build something really like great or something which you can export from here. So I think that's a good way to start in India, is what I believe. Manufacturing is definitely better than consumer, because manufacturing has clear-cut, like measurement of value, and in like other spaces, probably the cheap labor argument would definitely kick in, cooking, cleaning and stuff. So I think that's a good way. And the other way I also like thought about this problem was that maybe other way of building a business can be to help these labs who are building the models, right? Like in a way that we are building the data infra. So what else can we do? And it's a very big challenge from data collection to curation to giving. So like simulation itself has like bunch of problems that we can solve. If we go verticalized, then there are like, you can take a niche, work on that. How you can for simulation, one problem that I am personally facing is the compute cost, right? Like for running some of the iterations, the computes are just like prohibitive, like getting GPU itself is like so hard these days. So how we can solve that with less compute, less iterations, we can make the model learn faster. How we can do help them in the labs in post-training and deployments. So things like that is also a way to probably think about business also.
Yeah, so I was in a workshop in somewhere in Europe, and there were a bunch of engineers from Bosch, and they were sent to this workshop just to decide what they can do with the humanoids that they just bought, right? And so they were tasked with coming up with something. So there they were for like 4 days, and on the second day during lunch I asked them, so you have any ideas? And they told me they're going to just go back and say, it's not ready yet. This was also mirrored by another conversation I had with other integrators, so automation integrators, and they were also I see a lot of ABB, KUKA, etc. Automation companies showing up to these places, and they want to catch up, they want to play a part in physical AI. And almost everybody is eagerly looking for a way to deploy. So I don't see, at least from a European point of view, it seems that the customers are showing up to the automation vendors and asking them for a solution. And it's not in the big cities, it's also in the smaller cities. So the question is that sure we are in India, but we don't have to limit ourselves that way, right? Because maybe an easier access market, maybe through automation integrators who already have the connections, and maybe you don't worry about going directly to end user, and you instead kind of support pilots that your automation integrator figures out. But yeah, I would not be too optimistic about how well the pilots are going to go, because they also depend on expectations that the factory is having. I mean, if they're watching these videos about humanoids and they're not ready to settle for a bimanual, it's going to be also a hard sell. So only time will tell how we're going to navigate this, but I'm fairly optimistic that the need for automation is real because of the reasons mentioned.
And definitely, even for selling to the SIs or the integrators also, you need to have a certain should have achieve something, right? And then reaching there itself, I think most of the startup would struggle, right? Because we need to get funded, spend maybe a year or so to build it.
Yeah, so I think if we go to like what to build, right? That was the question. So I think definitely web-based teleoperation things that were discussed are like great things to build. I think what is it, environments are
Yeah.
great thing to build.
I think software first should be
Sure.
like a way forward.
Sure, right?
Hardware is like costly and hard both, right? So.
Right, and also, I mean, the sim to real question, I mean, there are probably great things to do in the sim world, even if you're just training a model. I mean, one of the things we participated in was like a data set for Counter-Strike, right? So, for example, imagine taking that kind of a data set and training a robot in sim that can do what Counter-Strike players do in that kind of environment. I mean, that's completely accessible to students and I mean, you can start simple. Why do you have to, one thing I would definitely recommend is start more simpler than you are thinking, right? Because it's not how fancy you can be, it's actually how deeply you get it. Because most people just walk around not getting it, you know? And they're just pretty satisfied with just knowing the name of things, right? So can you like dig way deeper and like really build something that according to you is simple, but it actually is going to build like amazing insights that then you can do complicated things with.
That's a great advice, actually.
Maybe at my perspective, right? I think the opinion is software is easier and hardware is hard. Yeah, of course. So the thing is, I would say like given where we are and the given kind of geopolitical scenarios, right? I think India deserves its own physical AI. When we say physical, so hardware is the core to it. So I think that ecosystem must get created here, right? When we started building our robots, we started with the obvious path of procuring actuators from elsewhere, but building hardware locally, such that it can have business value. I think that's a very important object. I think that's the important objective one should have. Otherwise, you would get swept by the wave of all the robots that will come in here from our borders. So,
hardware is not individual starters to solve. They start and do things about it. But then what about the geopolitical thing that you mentioned, right? China has full control on the raw materials processing of magnets, which are so important for your actuators. The battery ecosystem, they own it. So ultimately, you're gonna be constrained. So I think that is something out of our hands for now. But I definitely see that ecosystem needs to be built. How we are doing for the chips ecosystem right now. We are having fabs built out. We are I think recently read that ASML has given license data to build fab in Dolera. So I think we should also double down on the future robotics demand and build an ecosystem around that as well.
Also, here's my thought on robots for India, right? So India has the most number of people. We have a lot of unemployment, and if, for example, a political system was to create a lot of jobs, it's only going to be a good thing, right? It's going to be good for them. Yet, our toilets are not clean, our roads are not clean, right? These are clearly things that humans are dexterous enough for. It's clearly not that we lack one of the resources that would be required to do this. It's just a question of we've not been able to do this, right? And I do think I'm going to put my bet on this, that robots are the thing to solve it, right? And it's going to be low-cost robots. It's going to be, you see, I have a tattoo of Wall-E, right? So yeah, I mean, I think it's going to be something as messy as that. That's going to solve a lot of problems for India.
I think the local robots should solve local problems. I think I think there's few startups which are trying to do that. I think difficult terrains and so on and so forth.
Yeah, it would be awesome. I think it's also not very expensive to build if your goal is to build it low cost, right? So I think that also could be something to consider.
Yeah, So my point is also like, why not, why stop at actually building smaller robots? Like, I think be ambitious enough that, take up those kind of challenges where we are building some of this fund. So maybe not like, so some of these actuators which have rare earth material dependencies, right? So some of the things you could also be looking at as rare earth free motors. Like, can you build that? Like, I don't know if the audience have like hardware folks, I don't know, but think about it, right? Like that's one. And building hands, for example, right? Like there are again two types of approaches where one which are tendon based and another is like micro QDD based. And you build those micro QDD actuators. So these are some of the problems that you may want to solve for.
Yeah, these are pretty amazing problems, right?
Sure. I think it was a great conversation, and I think the purpose of this conversation is served. Like, I'm pretty satisfied with the nature that this conversation evolved.